Welcome to the Module 6 review. Hopefully, if you've done this, you've worked through the homework, and you have worked through all of the packet, you will be ready for the exam. And the exam is somewhat similar to the review, the packet, and the homework. So if you've done those sorts of things, at least you'll be ready to take the exam, which is next week. So let's get into some of the problems here. First couple questions are just kind of identifying a couple things from the actual packet. So the first is identify George Poya's 4 principles of problem solving. Now, this is from the first video. It's from the beginning of the packet, but the principles are understand. So we want to understand the problem. That's the first thing that we need to do. Second thing is devise a plan. Third thing we do is carry out that plan. And then the last thing we do is look back. So first thing we want to do is understand the problem. Second thing we're going to do is devise a plan, is how we're going to attack the problem. The third thing we do is we carry out that plan. And the fourth thing we do is want to look back and kind of reflect and make sure that we do have something that's reasonable and something that seems like it could be the right answer. Okay? So 6 different strategies that we discussed in this module, and some other ones that you've probably employed in the past are just these. So I'm just going to list some of them. So everyone's favorite, we really didn't talk about it in here, but most students do it, is guess and check. And we did start coming up with some different table values and thinking about those things using a guess and check type thing. The other thing we do is we've solved a simpler problem. So we've done that. We've made tables. So table or chart. So we made tables and chart. Drawn pictures. Look for patterns. Work backwards. Used variables. This is just 6 of them. There's more. You can look through the packet to find more. But those are the first 6 that kind of came to my mind. So I'm just going to run through those and talk about that and get on to some of these other problems. Now here's the deal. Mike has 5 times as many books as Lori has, and 10 more books than Sue. So because we're comparing the number of books Lori has and the number of books Sue has to Mike, we always want Mike to be the variable x. So that's what we're doing there. Now, we're going to express the other 2 in terms of our variable x, Mike. So Lori. So Mike has 5 times as many books as Lori. Another way of saying that is Lori has 1/5 of the books that Mike has. So if Mike has x books, Lori's going to have 1/5 x. So who has more books, Mike or Lori? Well, Mike has 5 times as many. So if we divide the number of books Mike has by 5, then we're going to get the number that Lori has. And we do that by multiplying by 1/5. Now, Mike has 10 more than Sue. So Sue. So question, who has more books, Mike or Sue? Well, Mike has 10 more than Sue. So Sue is going to have 10 less than Mike. So if we think about how many books Sue has, that's going to be x minus 10 right there. So that's what we have. Now the second, or part B here, asks, what is the sum of all of their books? Well, how many books does Mike have? We're going to add the number of books Mike's have, to the number of books Lori has, to the number of books Sue has. So when we get this, number of books Mike has is x. Number of books that Lori has, well, she has 1/5 x. And number of books Sue has, well, she has x minus 10. And this is the sum of the number of books. Now we know sum means add, so we can add those up. Now, one thing we could do is we can combine some of these things. If we have x plus another x plus 1/5 x, well, we're going to need to get a common denominator to add these things together. And because x is 1x, we can make this a 5/5 for our common denominator. Because this is a 1x, we can make it a 5/5x. And then when we're adding these up, because we have that common denominator, 5 plus 1 plus 5, That's going to be 11/5 x, and then we have our minus 10. So that is the sum of the number of the books they have, and we probably do want to simplify these sorts of things since we know how to do those now. Now the next one we have is this: express twice the sum of a number in 8. Well, twice something means 2 times it. What are we multiplying by 2? Well, we're multiplying a sum. Sum meaning add. So we're multiplying something that we're adding together. Well, what are we adding together? Well, the sum of a number and 8. A number is x, sum is plus, 8 is 8. So really, we can write this as 2 times x plus 8. Or we can use our property of distribution here to simplify this a little bit. 2 times x is 2x. 2 times 8 is 16. So that would be a way to express the sum of a number and 8. Okay, so looking at this next one, Jeff cut a strip of metal into 3 pieces. So let's just, that's a piece of metal, there's a piece, there's another piece, there's another piece. One piece is 4 times longer than the shortest piece, and the other piece is 2 more inches than the shortest piece. So we're comparing the long piece and the other piece to the shortest piece. So we want the shortest piece to equal x. So I'm going to write that x there. Say x equals shortest piece. Okay. Now, it goes on to say that one piece is 4 times longer than the shortest. Okay. So let's say one piece. 4 times means 4. We're multiplying by the shortest piece. So one of them is 4x. This is the longer piece. Okay. Then it says the other piece is 2 inches more than. So 2 inches more, we're adding 2 to something. So here the other piece is going to be x plus 2. And now what we've done is we've defined the shortest piece to be x. The next one is 4 times longer, so that's 4x. And the last piece is 2 inches more than the shortest piece. That's where we get our x plus 2. So next one we have a large picture frame is 15 inches by 18 inches. So let's just draw this out right here. 15 by 18 inches. Okay. Now what we have is this. We have a border around an 11 by 14 inch in hole for the photo is used to sign names and leave messages. What is the area of the space around the hole that is used for the signatures and messages? So what we have is we have this large picture frame. Now we have a border around an 11 by 14 inch hole. So essentially we have this picture frame. In here we have that hole to put the picture, and then this is the border we're talking about where we can put the sign, where we can sign names and leave messages. So we're trying to find out what that is. Now the border around 11 by 14, so we think this is 11 by 14 inches. So we're trying to find this area that's right there. So once again, we can find this by taking the whole black area, and then if we assume the red area is in here, subtracting off that red area that's in the interior, and what that's going to do is that's going to give us that exterior piece right here. So the dimensions of the black rectangle, we have 15 inches by 18 inches. And it doesn't matter where we put these dimensions. We find by area by multiplying. So if we multiply 15 times 18, that is going to give us 270 inches squared. Now, this red one is 11 by 14. To define that area, 11 times 14 is going to be 154. So we're subtracting 154 inches squared from that. So this exterior border piece that you could sign and I guess leave messages and signatures on is the difference of those. So 270 minus 154 is going to give us a grand total of 116 square inches. And that's how much area we have all the way around there to sign names and do those sorts of things. So it looks like I am going to break this into a couple different pieces. Go ahead and publish this now, and then I'll pick it up at 7 on the next video.